welcome everyone. I think kind of did a good introduction. I really want to drive the point home in this presentation. So I'm Sean Miguel, I'm research physical scientist at Coastal Hydraulics Lab. I started in 2020, and that was really the last year I think that SBAS as a whole kind of reached out to the community at large. We had a virtual training session at the 2020 Fall Coastal Working Group. And since then, we've worked with a little bit of the districts, but we haven't had too much of a large presence. There's been many new employees both within ERDIC as well as the districts who might not be aware of this tool that's available to them. So Tanya had a great idea of maybe doing this discussion so that way we get that out there, gauge some interest for some future workshops and training opportunities. So the basis of this presentation today, we'll talk about SBAS as a whole, where it started, where it's at right now, talk about some of the really cool work that we're doing this FY and the coming FYs, and the SBAS as a whole, kind of looking ahead and as it evolves for the needs of both districts and research. So for our outline, I'll go through the current team. It kind of ebbs and flows as the years go by, depending on what we need. So I'll talk about our current team. I'll talk about sediment budgets as a whole, as well as the sediment budget equation that SBAS is based off of. We'll do a real quick dive into SBAS history. Then we'll dive into the discussion of the tool a little bit. We'll highlight some of the current efforts that are going on by the team, which I think are really exciting applications and new innovation for developing sediment budgets, helping create tools to create sediment budgets, and then kind of pulling it all together and looking ahead and see where SBAS is going in these next, 1 to 2 years, as well as the 3 to 5 year timeline. So as I said, the team kind of ebbs and flows. Right now, we have a lot of projects that were focused on the remote sensing effort. So we had Brittany Bruder, Adam Collins, Tanner Jernigan helping out a lot with the imagery. We used a lot of the field cams I displayed at the beginning for some of our projects. We'll talk a little bit. And we have our core team. We got Rose, Ashley, myself, Charlene, Justin, and Keith. And then we got Michael Hartman also helping out with a lot of the core showing analysis that's going on. So we have a lot of ebb and flows just on what we're doing that year, which is, I think, really great to kind of pull in some people, train them up, and get that word out. So sediment budgets as a whole. When we think of sediment budgets, I know everyone hears the word budget, and the first thing they think of money. This situation, we're just talking about we're budgeting where our sediment is, where it's coming, and where it's going. These can be used for financial decisions at the O&M level, but for the most part, it's just where your sediment is, where you have your areas of accretion, where you have your areas of erosion. Your sediment budgets can be very rough in the resolution and the data quality, so we could be looking at maybe just a small inlet with 1 or 2 data sources just to get a general idea of where the sediment's going. We don't have to quantify it, just very conceptual. And we can evolve that into more developed budgets, pulling in multiple different data sources, having a higher resolution, or in some situations, just having a very, very large regional budget, whether it's a budget for the entire state, a budget for an entire district, or even division. So it can really vary just on both the data that's incorporated as well as the spatial extent. One of the nice things, sediment budgets are very visual by nature. So it's a good communication tool when you're working with stakeholders to show a figure and say, hey, here's where your erosion is, here's where your accretion is, here's where your sediment's going. Because that visual also helps with a lot of your project development. So if you're doing like a feasibility study on building a new jetty, you can start with that general base sediment budget that you've developed, and then you can modify it with some model results to see how that would change the system. Or if you want to start dredging and placing that on a nearby beach, what's that going to do to the sediment budget in that area as a whole? So we're talking sediment budgets. I keep talking about fluxes and cells. We'll dive into what exactly I mean by that if you're unfamiliar. So imagine our hypothetical beach we have right here, and we have our cell, that's our dotted box around our ocean and our beach, our sediment budget area. And we're going to have different sediment inputs and outputs are sinks. So our sources are any way that the sediment's coming into the cell. Our sinks are how our sediment's leaving the cell. So it's very slow animation right here. So some of our sources that are going into the cell, we're going to have our longshore transport coming in. We might have some cross-shore transport. If we have dunes, eroding bluffs, we're in the Great Lakes right now, so bluffs are a good source of sediment in the Great Lakes. As those bluffs erode, we're going to have sediment coming into our littoral cells. At the same time that we're having the sediment come in, we're having it also leave this cell. So longshore transport carries it in, can also carry it out. You have transport offshore, out past the depth of closure, so it's no longer part of the system. And you can also have it wind blown, so it's taken out of the cell, maybe it's blown further up into the dunes. Additionally, those are just our natural processes. So we have some other components. So we have our natural changes of beach, so whether that's the eroding or accreting. We also have our anthropogenic influences, so if we're doing placement on the beach, if we're doing dredging, if our cell, in this case, the cell's over the beach, but if we had a cell over an inlet, dredging would be a component that we need to consider. And we can take all these values and we can plug them into the sediment budget equation right here. And this helps us understand where all of our sediment's going in the cell. So we have our Q source, which is our input sediment into a cell. We have our sinks, that's all of the sediment going in, subtracted by all the sediment that's going out. We'll subtract our volume change, so any of the natural change in the cell. If we have placement in the cell, like I said, beach fill or placement of dredged material, I think our goal by 2030, 7% by 2030, this is a good example of being able to quantify that, as well as our removal from our cell. And that gives us the residual. And one of the key things I do want to highlight, and I stress this every time, is if you have a residual of 0, that means you have a balanced cell, meaning you account for all of the sediment coming into and out of the cell. That does not mean that the cell has net change. You can have the residual of 0, but you could have a highly erosive cell. All that's meaning is that's just your budgeting where you're doing all your math at the end saying, did we account for all the sediment? So that's one confusion I sometimes run into, and I really want to stress that right there. Sorry, got knocked out. So as I said, we have different types of budgets depending on both our spatial extent as well as the quality of the data. So I laid out these three right here, starting with our conceptual, which we'll give a few examples later in this presentation. This should be your fast sediment budgets. This is going to be kind of you're laying the foundation for any future budgets. This is as simple as just drawing where your areas of interest are and saying, is there erosion or accretion, which way is the sediment going, and no quantifying to it. That could be considered a conceptual budget. Or you can start pulling in some existing data or literature reviews, or maybe you did a small little study and you've got just one data source you want to incorporate. From there, you can build on that in the interim budget, and this is where you can start incorporating some historical data. Maybe we've pulled some dredging records. We've taken our CSAT results. So we've gone in, we've seen what's the rate of shoaling in these inlets. Looking at our shoreline change over time, whether that's from remote sensing products or if we're running some numerical models such as like GenCade. And then finally, we can build on that even more into our operational budget. I like to consider this, I'm not an engineer by trade, but, I know as PEs, you're allowed to pretty much stamp, hey, this is official. This is where the operational is. This is, yes, this is our complete data set right there. You can develop this with multiple data sources. So maybe you're getting your volume change from shoreline, you're getting it from topobathymetric LiDAR, you're getting it from modeling, and you're combining those three into one to be able to get one value for your volume change. So you're pulling in multiple different data sources for that. You're making it as refined as possible, and you're making sure that you're not missing any data gaps right there. As I said, we got a different spatial extent. So just using, for example, since we're on site right here, I've shown, this inlet. That could be a local budget that we could create right there. We could have done a cell right at the inlet. We could have done 2 cells on the adjacent beaches, and we can look at how the sediment changes in those areas. So we can do some surveying within the inlet to get our shoaling rates. We can use some of the camera imagery to get our volume change in this area. And we can do that all the way up to a regional scale. So that's what I was talking about, where we have budgets the size of entire districts, entire divisions, entire states. And then the macro is just where we can kind of clump some of those areas together into like one cell. It's kind of the mix between the local and the regional, especially if you've made the local and you're trying to develop a regional budget. You have a lot of smaller cells. You might pull some of those together a little bit to incorporate them. So as I said, SBAS has been around for a while. Kind of just run through the history of it to understand where we've been, where we are, and where we're going ahead. This was developed by Julie Rosati and Nick Krause back in the 90s as a standalone executable on Windows 95 and 98. Probably didn't have issues with your computer shutting down on you when you had that, which could be a plus side, so you didn't have all the capabilities that you have today. And it's pretty basic. It allows you to just pull in your data and just draw your area, quantify it, and print off an image, but nothing too fancy. Starting in 2000, that's when we started transitioning into the Esri products, starting with ArcView. So once you pull that into ArcView, we were able to then start actually making our maps out of it, making those really pretty figures that we can put to our stakeholders and such. And then as we went from ArcView to ArcMap, you know, Esri was expanding, making these stronger products so we could start processing larger spatial extents, including more data. Our most recent is the SBAS 2020. So ArcGIS Pro, and I'm going to do as I usually do. I'm going to step on my soapbox real quick. If you were still using Arc Desktop, we start transitioning to ArcGIS Pro. It's coming down the line of districts and divisions. They'll be a lot easier just to transition, get that little bit of a learning curve going. Highly encourage that. But SBAS is an ArcGIS Pro now. And one of the things that we did develop recently, which is nice, and using, again, that Esri suite, is the creation of an online hub, which I'll show you examples of. And the idea behind that is, you know, back in the 90s and 2000s, if you made the budget, you might save it on the floppy, put it in the filing cabinet, and then, you know, if that person who made that budget leaves, many people might know that budget still exists. So you might have to replicate if you're not aware of it. Or it might get lost if you know, for example, if your district changes office locations, it might inevitably get lost. So we wanted to prevent that. We wanted to save money, time, effort, and we wanted to create a repository where we could put all created segment budgets. So that way you can go and just pull existing budgets, build on that, reference them where needed, make it super easy to have it just in one location instead of emailing people or going and hunting in the repositories that are like the physical repositories. So the segment budget analysis system, here's a good screenshot right here. We have 8 different tools as part of this toolbox. As I said, you're creating and you're quantifying your littoral cells and your segment fluxes. In our latest SBAS 2020, we've added some new capabilities. So GenK, which is a shoreline modeling program, we've made that so you can pull in some of those results and it'll automatically add it to the cells. That's just one tool so far that we've done. I'll touch on our efforts looking ahead, but we want to expand that. Because the biggest complaint that I get with SBAS, you know, people who are unfamiliar with it, they get really excited, and they think it's just, hey, press go, boom, my segment budget's made. I have to explain, no, unfortunately, I wish we were there, but you got to run the models. You got to do the field work. You got to analyze the imagery. That reasonably so, we're all busy people. That pushes people away. They don't want that. So we're trying to get to that point where it might be more of a press play. You know, you've already done all that analysis, press play. Or you've done the analysis and you're not sure of some of the fine segment transport rates. You know, you have a calculator, you know, we'll pull that in. And then you're able to publish this to our SBAS hub, which I talked about. And here's a screenshot right here. As you can see, it's very sparse. We only have about 12 budgets, I believe, on there right now. I'm really excited that we have little yellow dots in Hawaii. That's a recent addition. But the idea is, you know, yeah, I know, same exact reaction, Tanya. It's tough. So one of our efforts, which I'll touch on, is trying to digitize as many of these budgets as possible, because I want this whole map bright yellow. I want everyone at every district to be able to go, hey, what's the segment transport in this area? Or is this an erosional hotspot? You know, I'm having calls from this stakeholder saying, hey, we're having no beach here, or we're having too much shoaling in this inlet. I want people to be like, okay, let's pull this up. Let's look at this. So as I said, we're trying to digitize right now. So part of an RSM-funded effort last FY and this FY was to start hunting down these budgets. So we pulled from all the previous grade or tech notes. We did literature reviews for any published by academia. I wasn't focused, or excuse me, the team wasn't focused just on budgets created with SBAS. If it was, you know, before SBAS or was just kind of drawn in ARC to quantify it, we were pulling those too. We were reaching out to the point of contacts to see if we could get the data. We were able to get some of the data. Hawaii was very gracious to pass us the data. So that's a quick, easy upload, but some we weren't able to. You know, as I said, I made that 10, 15 years ago. I have no idea where it is. It's been deleted. So we went in, we digitized them. So we've digitized 46 so far. We have one budget from each division. I'll say that. I won't say each district because we're not quite there yet. We have them ranging from small micro budgets, just looking at specific inlet, to entire regions. We have 18 ready for upload, and I pulled this from previous presentation last week, and I kind of joked, you know, I should have put just the states we had. I wanted to put the states missing. So I added that to the bottom right there. So our 3 states are Oregon, Washington, and Alaska that we have no budgets identified. So if you are from one of those areas and you're on this call and you know of some budgets that exist, please reach out to me. We'd love to host them for you guys, make that data easily accessible for everyone. Another effort that we have going on, so this is led by Justin and Alex. This is an RSM effort as well. We're looking at making a conceptual budget for Delaware. So there's been a budget that was created along the Atlantic coast, but there's nothing in the actual bay and estuary area. So we were trying to see if we could pull the data together, and kind of mesh that into one entire budget. How we're going about that? Well, we have some previous segment budgets. Marmeyer probably got that name wrong. I apologize. I can hear Justin kind of squinching up that I slaughtered that name. That was our estuary. There's a lot of missing data gaps from 1978. Lots changed since then. So we're trying to supplement some of those losses. We're looking at changes based on the beach profiles. We're looking at volume change using the GelTex Quick Response Toolbox. So any of the topobathymetric water that's been collected, we're doing that. We're looking at image classification. So Alex is leading that effort, looking at identifying shoreline from imagery, and we can see how that change has happened. Bathymetric change, same thing as the GelTex Toolbox, but you know, some of the hydrographic surveys in the inlets get that inlet change. So that's one of the efforts that's going on. Core cam. So as I said, I'm here right now. We're doing a core cam install. Or correction, excuse me. This is an example from Lynnhaven Inlet, which is an inlet in Virginia Beach, Virginia. And you can see how we had some change in the shoreline here. So between these two images, this is about the same water level. They did a beach fill, the city did, not the district. But you can see how much volume changed from that. So if we go back to our sediment budget equation, that's our p-value right there. That was that placement value right there. But we want to also find out what the natural volume change was. So Adam Collins helped out by developing a machine learning algorithm looking at the water versus not water. We tried to do even higher resolution, you know, water, vegetation, sands, infrastructure, about 10 classes, weren't getting good results. So we just went to water, not water. So you can see the top image on the right, that's our rectified image. We then go to water versus not water, water's in the blue, and then we can find the contour of that, run a transect, and we can find the change in distance over time. So this is still a little preliminary right here, but you can see, generally speaking, to the left before the beach fill, you have your change in beach distance, of course, as the water level changes. We see a pretty big increase in beach width after that beach fill. and then we start to get continuous change right there. So once we can take this, identify similar water levels, get a change over time, then we can kind of flesh that out and get an actual volume change from just the imagery. So that's been pretty neat to look at. We did try to look at surface currents as well, but unfortunately the cameras aren't, there's some resolution issues. Had that been the case, then we could have looked at a conceptual budget created strictly with camera imagery, getting your volume change on the beach and your sediment transport and near shore just from cameras, which would have been a great idea. You know, that would have been a cool selling point to extend to the community right there. But the beach volume changes, I think, is still a huge sell, which is pretty exciting to see that work right there. We have the sediment budget calculator again. So Julie Rosati also developed this about 10 years ago now as a standalone tool. And the idea was if you had unknown sediment transport rates into and around an inlet, but you knew the volume changes on the adjacent beach, you knew the longshore transport rates, what the inlet's volume change was, trying to refine some of those values. So if you look here, I'm talking mainly about these Q values on our right figure right there. So take all those, your thresholds, you say, hey, my volume change is kind of between, you know, these two values, my longshore transfer rate was between these two values, and it would give you this results on the left. And this would be all your different possible solutions. It would be a suite of solutions. And you click each of those solutions right there on the left, and it would display on the right what the exact transport rate's there. So that can help refine some of those unknowns around our inlets, whether you're working with just a micro budget focused on the inlets. This will help you supplement that. Or if you're working on a budget where you weren't able to get some of the data in that area, that can kind of help fill those gaps a little bit. Pete's leading an effort to look at Aeolian transport calculator. So very similar to what I previously said on the, with this, the idea is similar figure and similar products will be generated. The user would put in different components, but it'd be more on the Aeolian side. Because as everyone on this call is aware, Aeolian components have not been too deeply looked at from the sediment budget perspective. We kind of touched on that a little bit before. When we're making ourselves, we're mainly focused on the littoral area and you know, some of the subaerial beach, but we're not too focused sometimes on those dunes. So being able to understand how that sediment change is occurring in that area, we might be able to refine our volume changes just a little bit more. So Pete's working on that. He's got a pretty decent workflow where the user is going to take environmental data. So like from NOAA, your wind data, where it's going, the speed. The user will put in what their beach angle is, how wide it is, what the slope is, and then the grain size. And then it'll go in, take all that together using a couple different Aeolian equations, and we'll be able to find out some of the estimates for the sediment transport rates around those areas based on Aeolian components. So once this is involved, or once this is pulled into SBAS, we'll be able to find our sediment transport rates both from the Aeolian component and the littoral component as well. So that'll help the user better not only understand their area, but publish this data so people can go and look and say, okay, how much of this was wave-driven, how much of this is wind-driven. The future efforts, as I said earlier, the biggest disappointment, you know, I go and talk to people who are interested in SBAS, and they're super excited, they're happy, and then as soon as I say all the word that's involved, the smile just goes off their face, their eyes glass over, and it's a losing battle with me. So I'm envisioning trying to make it easier for users to pull on this data. So we're currently, this is what CIRP's finding. This is a statement of needs submitted by Elizabeth Godsey requesting automatic importation data from different tools. Because as of right now, unless you're using GenCade, you have to spend time pulling in CSAT. And if you have a budget that has multiple inlets with CSAT results, you then have to run CSAT on each of those, which is part of that. I can't change that, unfortunately. But then you manually have to add all those values into all of your inlets. Or if you're working with a JAWS6 volume change toolbox, same thing. You might have, 100 cells, and you have to manually add each of those. So we want to go ahead, pull all these data importations in easily. So we can get COSAT, we can get some volume change. CSAT, we can get volume change in the inlet. Java text, volume change on the beach. As well as both of the calculators I mentioned, Pete's Aeolian calculator, as well as Julie's sediment budget calculator. Right now, both of those, Pete's working on the Aeolian. The sediment budget calculator that Julie made is still in beta testing. We've pulled it in, but we haven't released it straight to the public. And I want to take these four. I want to release SBAS 2025, the next big release update. And that way we can pass it to you guys, and you guys will have the newest, latest, and greatest tool. But that's not it. So that's our 1 to 2 year time frame right here. But I want to think even further past that. So recently last year, we added an ability for users to be able to modify sediment budgets online. So we have a data repository with a whopping 12 budgets right now. And in the near future, we will have tons of budgets on there. And we want our users to be able to go say, hey, this is my budget of interest. I want to just tinker something real quick. I'm in a meeting right now. We're talking about doing a nourishment on this beach. What would happen to the system if we start nourishing it more? So right now we have this conceptual budget creator, and you can select your alternative online. You can quickly modify the cells, and in seconds, it'll tell you what that's going to do to the system. So that's the first step, but we want all the SBAS to eventually be on there, because we all know the issues that arise with ArcGIS sometimes. If you are in an area where you can't connect and you don't get that license, you might not have access to it. So having everything online, being able to immediately pull it up, maybe draw yourself, do everything SBAS does on the desktop and have that available online so you don't have to pull it into Arc and work with it. That's the goal in the next 3 to 5 years, having everything there for the user so that way it's quick and easy as possible. Like I said, everyone on this call is busy. We're all busy. All right, like I said, I'm in the field right now giving this talk. So I completely understand that. I want to make it as easy as possible for everyone. So kind of just wrapping up, as I said, I consider SBAS the premier sediment budget tool. Yes, it's used by USACE a lot. We're starting to get some use by other federal agencies as well as academia. But this tool is designed for the district user in mind. So that's why we want to cater it to make it as best as possible for you guys. As I said, we have many different efforts underway that are working to increase data availability, so working on digitizing those budgets, as well as exploring new sediment budget creation methods, whether it's using the CoreCam imagery or using the Aeolian sediment transport calculator, pulling those in to make that easier for budget development. And then finally, we're looking ahead. We want this to be easy to import data from different tools, easy to access and manipulate those budgets online. So that way the sediment budget creation process as a whole is faster, cheaper, and easier. That's the end goal. That's the goal for probably 90% of the work I do is just try and make it faster, cheaper, and easier for everyone.